Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of a binomial distribution, and you will see that it has actually been extended from the idea of Bernoulli distribution. So in Bernoulli distribution, we have this x random variable that represents the number of success, and the setting of this experiment is such that you have either success or failure, and so x can take values such as 0 and 1. So that's in Bernoulli distribution. So in this binomial distribution, what we have is we have an experiment that is similar in nature, such that it has two possible outcomes, can be denoted as success and failure, with probabilities p for success and 1 minus p for failure. Now, the difference is that this experiment can be repeated again and again up to n trials. So you can think of it as having a Bernoulli experiment that is repeated again and again. Okay. So in these trials, they are all independent. Therefore, probability of success is going to be the same for each trial. And in this binomial distribution, we have a random variable x that also represents the number of successes. So the number of successes can be from 0 up to n. Okay, so you can think about, for example, if you repeat the experiment n times, and let's say you get unlucky every single time, that means you always fail every single time. Therefore, your number of success is going to be 0. Now, on the other hand, you can repeat the experiment up to n times, and let's say you get lucky every single time, so you observe success in every experiment. Therefore, the number of success that you get will be a maximum of n times. Okay, and of course you have the combination of success and failure and success and so on, so those will fall in between of 0 and n. Okay, and to find the probability of getting 0, 1, 2, 3 and so on, you can use this formula. So this is the probability mass function for random variable x that is expressed in terms of equation. Recall that probability function can be represented in 3 ways. So we can have it represented in terms of equation, in terms of table, in terms of graph. Okay, right, now you can see that this formula right here, we have p and n, so those are parameters. Basically, parameters are just constants that will influence the shape of the distribution. It would influence the shape of the graph, and we will look at it again towards the end of this video. Okay, right, right now what I'm going to do is I'm going to explain to you in a rather intuitive manner how this formula for finding the probability of observing x number of successes in a binomial distribution is obtained. Okay, and you can see that this one here has got something to do, or is closely similar to what you have seen in Bernoulli distribution, where you have this where you have this one right here with parameter p, and the formula to find the probability of that is going to be p x 1 minus p 1 minus x for x 0 and 1. So this is what have been observed in the Bernoulli distribution. Okay, And to explain how the formula up here is constructed, I'm going to consider a very simple scenario of having the number of trials up to 3. Okay, so this is what we're going to do, and we're going to try and visualize this using a tree diagram. Okay, all right, we are going to start that right now. Okay, so this is the first stage where you run the experiment for the first time and you observe success or failure. Next, you can do it one more time, you get success or failure, success, failure, and the last time, success and failure. This is the case where you have up to n equals to 3. So the number of trials is 3. And we have probabilities associated with all these outcomes here. We have this probability here of getting success is P, P, and P. This one is 1 minus P. This one is P. This one is 1 minus P. So on. P and P. 1 minus P. Okay. So these are all the probabilities, right? Now, as always, we can come up with the sample space. So what are sample space? Sample space is the list of all possible outcomes, the outcomes that you can observe in this experiment. And you can see that for this one here, the sample space is you can observe success, success, and success in n equals to 3 number of trials, or you can get success, success, and failure. So that is the next sample space. Or you can have SFS or SFF, or failure, success, success, failure, success, failure, 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 success, and then failure for 3 consecutive outcomes. Yeah. And next, what we can do is we can change the outcomes observed in the sample space into some values related to a defined random variable. So let's say here our random variable here is x, and it represents the number of successes. Okay, so the number of successes in this case is going to be equal to 3. For this one, 2. This one is 2, 1, 2, 1, this 1, and this is 0. So these are the values of random variables, and from this one you can see that x can take either 0, 1, 2, and 3. Okay. Now let's say we are interested to find the probability of getting 2 successes. Okay, so how can we find this probability? Well, simply said, we can consider, well, the outcome of getting success, success, and failure. So in this case, we have 2 successes. Well, what's the probability of getting this path, really? So that's what we're going to do next. Let me just erase this. Right. Okay, so if we talk about the probability of that particular path, it will be multiplying these probabilities together. So it will be P times P times 1 minus P, which I'm sure you can see this can be written as P to the power of 2, 1 minus P to the power of 1. And let me just tell you, this is what has been represented in the formula really. So this one right here is what has been represented on this part, where you want to perhaps find a specific way of getting two successes, let's say, yeah. And if you see the construction of this part, it is very similar to what you can observe for a Bernoulli distribution. The difference is at this point right here, where here we've got the value of 1, and for this one is replaced with n, because you repeat the trial up to n times. Okay, now we are not done yet, because there are many possible ways of getting two successes and not just this one path right here. So other ways of getting two number of successes can be clearly represented by this path: success, failure, and success. And another one is failure, success, and success. Right, so let us try to obtain the probability for each path. The probability for each path, for example, this one here is p times 1 minus p times p. So we have p 1 minus p times p, which of course can be written in this manner, so that it looks similar to the one above here. And this is just p squared 1 minus p. Okay, similar value really. And for this one, we have 1 minus p times with p times with p. And again, this can be written similarly as p squared 1 minus p to the power of 1. And we know that the probability of getting two successes can be obtained by adding up all these three probabilities. Now, instead of adding up, we can also say that you can multiply the value here with 3, right? For example, if you have simple value, let's say you have y and y and y, so you want to add them up, so it will be y plus y plus y. Or you can simply just take this one, because they are all equal values, so you can have 3 times y, right? It is the same thing. So the part where you consider adding up all this, or what we're going to do now, is given by this one right here. So you're multiplying one way of getting two success. So this is just one specific way. So this one here is the probability of one specific way of getting two successes. But as I said to you just now, two successes can be obtained in many other ways. For example, we can have SFS and then FSS. So you need to consider that scenario as well. And the probability of getting two successes can be obtained by multiplying this value with 3. Okay, because the same value here occurs 3 times, yeah, in this case. So how do we know how many times you want to multiply? Is it 3? Is it whatever? So that one is given by this part. This part here is to the process of multiplying one value, one probability of specific way of getting two successes, for example, and you multiply with that how many times, how many other possible ways. Okay, so this one here is actually NCX. It's a combination. and you can find it easily. The value of that can be found in your calculator quite easily. Or if you want to know what's the mathematical representation, it is n factorial x factorial n minus x factorial. Okay, right. So I hope that with this example you got some idea on how this formula comes about, like what's the rationale of, for example, having this part. What is this part all about, or what is this one all about, and how come it is related to Bernoulli distribution, for example. Yeah, okay, so we are done with that. Now I'm going to talk about how the probability function of a binomial random variable can be represented in terms of table and graph. So let's say we have a binomial distribution with p equals to 0.2 and n is equal to 20. So in this case, we know that the equation is going to look like this. Fx is going to be 20, x 0.2, and then you have x 0.8, 20 minus x. So that's how the equation is going to look like for x equals to 0, 1 up to 20. Okay. Now another representation is using table, and to use a table it's going to be a bit massive because our table is going to look very huge. So this is an example of representing the probabilities in a table. So here we are focusing on 0.2, and this one is the value of n, and these are all the value of x. X here is the number of success from 0 until 20. So you'll be looking at this part, at these probabilities right here. Now this table, well, you should be already familiar with because you have seen it when you were in school, when you were asked to find the probability of the number of successes in a binomial distribution. So this one is a complex table really, but that's the idea. We have to go for p 0.2, we go for n is equal to 20, and these are all the values of x associated with that. And if you want to represent it in a graph, using graph, you can see that if I ask you what's the probability x is equal to 3, so you can go to this part. So the probability is 0.2054, and if you want to look at the value of it using a graph, so you can go for 3, so 0, 1, 2, 3, so this is 3. The value here is about this point, which is about 0.2054 maybe. Okay, it should be, not maybe, it should be. Okay, so you can see that for x equals to 0, this is the value, which is if you look at the table you get more specific reading, 0.0115. okay, and of course if you want to use the equation, you just have to plug in, sorry, where is it? If you want to use equation, then you just have to plug in the value of x equals to 0, and you will get the result as shown in the table. So basically that's how probability function can be represented. Again, this is equation and then table or graph. Of course, using equation is easy, it is more compact, and you can just replace whatever value of x that we need to find. Okay. Now where are we? Okay, right, so let us try do some simple example. Find the probability that 7 out of 10 persons will recover from a tropical disease if we can assume independence, and the probability is 0.8 that any of them will recover from the disease. So this is an experiment where the probability is the same for any of them and you assume independence. So basically here we have n is equal to 10, and then recover from a tropical disease is a success, and therefore this is x is equal to 7. The number of successes is 7. If we want to represent this situation using a tree diagram, basically we start off with observing the first person. The first person can recover from the disease or won't recover from the disease. The probability of that person recover is 0.8, and the probability the person doesn't recover is 0.2. And you will continue with the next one, investigating the second person. So we have the second person. You see whether this person recovers or not, and you're going to repeat this process 10 times basically. Okay, now to find the probability that x is equal to 7, we can just apply the formula which you have seen in the previous slide, which is the formula is looking like this, and we're just going to replace all the values that we have figured out. For example, n is 10, x is 7, p is 0.8, so 0.8 and then 7. Okay, you want x equals to 7. This one is 0.2, and then 10 minus 7 is 3. Alright, and we'll be able to get the results on this part is 0.00168. You multiply that with this result here, so this is NCR. If you punch in the values in your calculator, n is equal to 10 and r here is 7, so NCR, and the result, the final result should be 0.2013. Okay, right, now this is the last slide for this video. We can see that we have two parameters. N is the number of trials and P is the probability. So if we change the values of these parameters, the shape of the graph will also change slightly. For example, here we have N equals to 20, P is 0.2. So you can see that it gets really centered around this value here, 4. And for this one, n is 20, p is equal to 0.4, and this one is you have bigger number of trials, p is 0.3. So you can see that there are slightly different shapes depending on the values of the parameters. Right, the mean of the random variable here is NP, so this is expected value of x, and the variance here, the variance of a binomial random variable is given by this one. And in the next video I'm going to talk about how we can prove these two results that we have here. Alright, that's all for now.